Now for this phase, it's over. Now we need to take the slope portion because wind load is also supposed to hit on the building slope. So we are first selecting one half of the building or one part of these two slopes. So we are removing this cross bracing from the selection. Just to show you, if you want like any of the member to be ignored from this panel definition, you can deselect them. If you think like this intensity is not going to impact on those members. So what we did is we have taken the other side of this building as a same panel group name because in the other side we didn't consider there is any opening. So we have taken the entire the slope portion as well as the vertical wall within the same group name, and we will apply the wind load with the same intensity to this entire stretch because there is no opening, so there is no point in fragmenting them. Every panel should be considered. Okay, now the dead load. Uh, so all the definitions, group definitions, the win definitions, and other inputs are defined. Now we will define, or rather we will apply the win load and the dead load here. So first of all, go to the flow load after defining the load case name. Now you can use the range option. This is a very easy and quick way to define the wind load. Just define the range, and even if you do not define any lateral direction, it will take the maximum available area within the view of the display and the load would be applied. So once you have applied as a by the virtue of range, you can see there is some issues while generating the loading. There are several reasons. First of all, there is slope. Please note that this range option basically works for the perfectly horizontal coplanar floor system. So if there is any inclination or if there is some inaccuracy in the panel geometry, then generally this option fails to apply the floor load. So there is another way to fix this issue. You need to use the group option. The group option is a very powerful option. Now, as I mentioned, in the group option, you need to define the group, but in this model, we have already defined the panel by some specific group name. So we'll select the group option here and see how we can define it to the required panels. So the moment you select the group, you can see two different panel names has popped up. Now these are the panel names that we have defined, like inclined 1 and inclined 2. Now define the respective pressure in load. Please note that these values are generally taken as some empirical value. They are not necessarily the realistic value. So just for this demonstration purpose, we have taken some values within the realistic range. But again, if there is some deviation from this realistic values, please go ahead and provide your own set of inputs. Okay, you can select the inclined option and you select the group name, and immediately you can see the loading has been imposed to the defined panel. Now one thing you might have seen, like these loadings are distributed on those panels as a two-way load. You must have seen some patterns of tributary distribution. Now in general, let's first apply it to the other side. So as we are discussing, like you can see the patterns of those distribution. It's just like two-way flow system where the loading of those flow load are distributed to its nearby or the perimeter beams by some geometrical patterns. We call it the tributary distribution system, or someone call it the ill line patterns. Okay, now basically this rule holds good for some slab where the floor slab is uh, normally this type of distribution system holds good for a building system where the slab is resting perfectly on the four surrounded beams within its perimeter. But here in this steel section, you just consider the metal sheet which is resting actually on the purlins, right? It is not resting on those flanges of the tapered beam. So basically, they don't behave like typical two-way slab system. Rather than that, they will behave like one-way slab. So you can rather select the one-way option. Just go to the flow load option, just select, and just select the one-way. Now, the moment you select on the one-way, you just define the direction. Just skip the default one, the longer direction, and you do it for the other half. Okay, now we have assigned for the first half. You can see the pattern or the distribution pattern of those flow load is quite different from the left hand side, because in the right hand side only I have modified as a one-way distribution system. You can see the pattern is completely different. It's like the load is divided into two halves and directly being applied on the parallel members. The purlin is, in our case, these parallel members. If you are not convinced with, like, if STAT indeed applied the flow load, then you can scale up the load vector display. In fact, there is no point in being skeptical, because you can see those color representation on those panels that indicates that flow load has been applied. But still, if you want to see those display of all those vector icons, go to this diagram setting scales and just keep on increasing or decreasing the values. You will get to see these vectors. Here in that case of two-way slab, you can see these are being imposed on all the four surrounded members. Okay, so I have also modified the loading distribution as a one-way load distribution pattern for the other half. Now, several users do not use this procedure to apply the flow load on those purlins. They straight away calculate the, because basically these loads are applied on the members, some parallel members. So these loads are applied on the members, and then these loads are generally acting as a member load. So some users directly calculate the member load, because calculation is very straightforward, because these panel loads are directly divided into two halves and being applied on two parallel members, connected parallel members. So they calculate the member load and define the uniformly distributed member load on those purlins. So either you can use the flow load or you can use the member load here. There is a very important point to note. For example, when you are defining any load case, you can see a small screen, or rather a dialog box appears, which shows you like information of primary load, and it will allow you to define the title of the load. Now there you can see some load level, or the load type. What is the loading type? Loading type is something like It will allow you to select the type of loading, whether you want to map it as a dead load, live load, wind load, seismic, and so on. Now, sometimes this selection is insignificant. Even if you ignore it, it won't impact your model. It's not going to harm your model. You can straight away perform the analysis and get the analysis result. But there are some benefits to map the loading by this loading type. Now, the most important benefit here is using the auto load combination. Okay, now what we'll do here is we will map or connect the load cases and define it by some loading type. For example, the first load I will take as a dead load and just map it with the dead as a loading type. Just give some title like dead load or DL, and I have selected the loading type as dead. Similar way, you can go on and select the other load cases like live load. Uh, okay, now okay, I have missed to define the sulfate. Okay, shell sulfate should be under dead load and select all the members and include them with the sulfate. Okay, now next is like the load that we are going to apply is the flow load for the live load case. Now give some values. I have roughly calculated some realistic value within some range and selected the incline option. And similar way, we have defined it in the dead load. We have applied it for the live load as well. Okay, so dead load, live load, all done. Next, probably we need to apply the wind load. Okay, now next, select the loading type as wind. Now here you can see there are different loading options, different loading type. So select as per your requirement depending on the loading. Okay, give some wind like WLX, considering the positive X, acting on the positive X direction. Then wind load minus X, or wind load Z, then wind load minus Z, and so on.